Good morning, everyone. So this is lecture number 7, and we are on to acceleration. If you remember, in the last class, we had dealt with velocity, uniform velocity, non-uniform velocity. We have seen the differences between average speed and average velocity. Do you remember? Average speed, average velocity, total distance divided by total time. And I also told you the with the question that we did, I also told you that direction of average velocity is same as the direction of displacement. It is from initial position to the final position. You all remember it? Then we had also seen the differences or similarities between instantaneous speed and instantaneous velocity. And I told you the direction of instantaneous velocity is always tangential to the path. Do we remember this?
Yes, sir.
Okay, you can also remember it in this way. The direction of velocity is same as the direction of motion. In whatever direction motion is happening, the same direction you have your velocity. Because in the direction that you have velocity, in that direction only you can have your motion. Do we understand this?
Sir.
So you can also remember the direction of instantaneous velocity as the direction of motion. Now we come to the heading of today's chapter, which is acceleration. Now, what changes velocity? A thing that changes velocity is known as acceleration. So the next heading is, the next character is acceleration. What do you mean by acceleration? Yes, anyone? You must be knowing it, right? What do you mean by acceleration? It is the rate of, define acceleration as the rate of change of, rate of change of what?
The rate of change of velocity.
Rate of change of velocity with time. Remember, velocity is a vector, so I'm using the vector. It is the rate of change of velocity vector with time. What type of quantity is acceleration? Whatever type of acceleration you come across, what type of quantity is acceleration?
Vector quantities.
It is a vector quantity. Now, as soon as this term vector comes, two things should come to your mind. What are those two things?
Magnitude and direction.
One is the magnitude, that is correct. One is the direction. Now, magnitude, you might have also heard about the magnitude in your 9th standard. We will obviously deal with magnitude, but the more important thing is direction. Where do you think is the direction of acceleration? Most of the students, even those who have cleared JEE, maybe some of them would be confused about what is the direction of acceleration. Can anyone tell me what is the direction of acceleration? Think, what is the direction of acceleration? In which direction you will say acceleration is?
In the direction of the force.
In the direction of force. Okay, that is correct. But see, right now we have not seen what is force, because force is going to come in the next chapter. So force only comes after acceleration. So I cannot say acceleration in terms of force, but you are correct. It is in the direction of force, but force has not come. So right now we have to only use things that we know, things that we know. So instead of force, think about something else that we know, that we have already defined. What is the direction of acceleration? Again, I ask the same question. It is yes in the direction of force, but force is still not come to the picture. It is a character that will come in the future in the next episode, not the next episode, maybe 10 episodes afterwards. I can't use force now. What is the direction of acceleration again? Anyone?
Velocity.
The, the only terms we have read now are distance, displacement, speed, velocity, and the various types of speed and velocity. So you have to give me the answer in terms of these quantities: distance, displacement, speed, velocity, whatever velocity. Yes. What is the direction of acceleration? Any idea? Okay. The direction of acceleration is the same as change in velocity. In whatever direction velocity changes, that is the direction of acceleration, because velocity only changes in the direction in which there is acceleration. Acceleration changes velocity. In whatever direction acceleration is, in that direction only velocity will change. Or if I say the reverse of it, whatever be the direction of change in velocity, that is the direction of acceleration. Do we understand this? Okay, whenever I ask about acceleration, the first thought that comes to everyone's mind, I think some of you also said that the direction of acceleration is the same as the direction of velocity. No, the direction of acceleration is not the direction of velocity. So you write it. The direction of acceleration, and remember this, direction of acceleration is not is highlighted. Direction of acceleration is not the direction of velocity. Then what is the direction of acceleration? Can you repeat it? What is the direction of acceleration?
Change in velocity.
Yes, the direction of acceleration is in the direction of change in velocity, and these two are completely different directions. Do we understand this? Now, let us now talk about the SI unit. What is the SI unit of acceleration? You must be knowing it.
Meter per second square.
Meter per second square, that is correct. What is the dimension?
LT minus 2.
M0, I will not write M0, I will just write LT minus O, I will minus 1, LT minus 2. Do we understand this? Now, what is the job of acceleration? The job of acceleration is to change velocity. Now, how can I change velocity? In what ways can I change in velocity? Can I change velocity? Velocity, V vector. Remember, velocity is a vector. I hope everyone is writing it. I don't see anyone writing. How can I change velocity? In what different ways I can change velocity? Yes. In how many different ways I can change velocity? Can anyone tell me? In how many different ways can I change velocity? Yes, there are three different ways in which I can change velocity. Can you tell me what are the three different ways? Anyone? Any idea? What are the three different ways in which I can change velocity? Velocity is a vector, remember. It has a magnitude, it has a direction. I have to change velocity. How can I change velocity? Yes. No one? I can change velocity by changing the magnitude of velocity only. Can you give an example for this? When your car is moving, on a straight road and you apply brakes, the direction of the car does not change. The magnitude of velocity or speed only changes. That is the example of velocity changing only in magnitude. If I throw this thing up, vertically up, at the point where I throw it, the velocity is maximum. As soon as it goes up, velocity decreases. So this is the case of velocity changing in magnitude only. Do we understand this? So motion under gravity. If I throw something vertically up, only the speed changes. The direction does not change. Oh, after some time the direction changes. So I'm not talking about that. I'm just talking about when it is going up or why it is coming down. You can change velocity by changing only the magnitude of velocity. What is the other way in which I can change velocity? It's pretty simple. Velocity is a vector. One way of changing velocity by changing the magnitude. What would be the other way?
Times.
By changing the direction of velocity. By only change the direction of velocity. The example for this is uniform circular motion. If something is moving in circles, with a uniform speed, something is moving in circles with a uniform speed, the velocity ka magnitude remains constant, but the direction of velocity keeps on changing. Take the example of Earth moving around Sun, or take the example of the seconds clock, the seconds hand moving. The speed with it moves, it's same, but the direction of velocity is continuously changing. Motion of Earth around Sun, it is moving with a constant speed around the Sun, but the direction is different at different times. That is the case when velocity changes only in direction, but it does not change in magnitude. Call it UCM, uniform circular motion. We will understand uniform circular motion when time comes. So I can change velocity by changing only the magnitude or only the direction. The third way is I change both. I change both magnitude as well as the direction. So I'm moving on a road. I take a turn. My speed decreases. My direction of velocity also changes. That is the case where I have changed both the magnitude as well as the direction of velocity. Do we understand this? Yes or no? Everyone in the class? Velocity can be changed. Acceleration can change the velocity by any of these three methods. Either it can change only magnitude, or it can change only direction, or it can change both of these. Do we understand this? Have you noted this down? What is the first case? The first case is velocity changing in magnitude only. How can I do this? By velocity, how can I make velocity only change in magnitude? For example, if I have a body moving like this with a velocity v, If I have a body moving like this with the velocity v, I only want to change the magnitude of velocity. Can you tell me what can be the direction of acceleration? I want to change the magnitude of this velocity only. How can I do it? What should be the direction of acceleration? The only thing that you must understand about acceleration is the direction. But if you understand the direction, then only you understand the vector. Velocity is like this. I want to change the magnitude of velocity. What should I do? What should be the direction of acceleration? Yes. It does not involve physics. It just involves common sense.
Opposite to velocity.
Yes, beta?
Opposite to velocity.
Opposite, or let us say it could be in the same direction. Yes or no? Could be in the same direction. Yes or no?
Sir.
What will happen if they are in the same direction? This case, what will happen? They are in the same direction. What will happen in this case? Case number one. What will happen in this case? If velocity and acceleration are in the same direction, then what will happen? Your velocity will increase in magnitude. Yes or no? Particle is having velocity in this direction. I am giving it acceleration in the same direction. Will the velocity increase or will the velocity decrease? Do you understand this? Do we understand this? Either we understand this or we don't understand this. Yes. Do we understand this? Yes or no?
Sir. Yes, sir.
Velocity. See, if you don't say, then I get confused. Huh?
Sir, can you explain once again?
If velocity and acceleration are in the same direction, what will happen to velocity? Your car is moving on a road and you put the accelerator, what happens? What happens in that case? Your velocity increases. Why it increases? Because your acceleration is in the same direction. So if acceleration and velocity are in the same direction, please note it down in your notebooks. If velocity and acceleration are in the same direction, and draw this diagram. Write it in your own language, may not be English. If velocity and acceleration are in the same direction, velocity increases. Draw this diagram, write in your own language. Velocity and acceleration are in the same direction. Velocity will increase. In your ninth standard, you call this acceleration. But that is not acceleration, that is just speed increasing. Acceleration can do a lot of things. Have you written this? Velocity and acceleration in the same direction, velocity increases. Now let us go to the case when they are in the opposite direction. What will happen if velocity and acceleration are in the opposite direction like this? What will happen in this case? Apply some common sense. Velocity is like this. Acceleration is in the opposite direction. What will happen in this case now?
Velocity decreases, sir.
Velocity decreases. The example is braking of a car. Don't understand braking of a car. When I throw this body up, slowly it goes up. Its velocity decreases. Why its velocity decreases? Because its velocity is in the upward direction, but acceleration is in the downward direction. Therefore, the velocity decreases in magnitude. To understand this, so you can write this. When velocity and acceleration are in the opposite direction, velocity decreases. In your ninth standard, you used to call it by a different term. You used to call it deceleration. Do you remember deceleration? That was your deceleration. There is no term as deceleration. It has been just made for this particular case. I will not write it as deceleration because there is no term which is defined as deceleration. There is only acceleration. If it is in the same direction, velocity increases. If it is in the opposite direction, velocity decreases. This is what we call deceleration. Do we understand this? Yes or no? That was the term of deceleration. Do we understand this? Now, remember, this acceleration, it changes velocity in magnitude, and we will understand more about this acceleration in your circular motion. But just now to tell you, this acceleration which changes the direction of velocity has got a particular name. This acceleration is known as tangential acceleration. Tangential acceleration. This acceleration is known as tangential acceleration AT. And the purpose of this acceleration is what? The purpose of this acceleration is to change. Oops, I'm using wrong color. The purpose of this acceleration is to change the magnitude of velocity, or I can call it, it changes the speed of the particle. This acceleration has got a special name. When the acceleration is in the same or the opposite direction, the actual name of this acceleration is tangential acceleration. We will understand more about this in the chapter on circular motion. Is it okay? Do you understand this? Yes or no? Okay, that was the first type of acceleration, and I will write it in bracket. This type of acceleration is known as AT, A tangential. You might not find this in books at this stage, but sometime you have to see it. You better not see it now. What is the second type of acceleration? What is the second type of acceleration? Second type of acceleration is velocity will change in, or velocity changes in what?
Direction.
In direction only. Velocity changes in direction only. It should not change in magnitude. It should change in direction only. Now let us say this is my velocity. This is my velocity vector. If you can apply some common sense, can you tell me what should be the direction of acceleration so that only the direction of velocity, it only depends on the direction of acceleration. It does not depend on the magnitude. And that is why to understand a vector, you must understand the direction. What should be the direction of acceleration, my dear friends? So that here only the direction of velocity changes. The magnitude should not change, only the direction should change. Can you tell me some thoughts? What do you think should be the direction of acceleration? The most important thing about acceleration, the most important thing about any vector is the direction. Yes, my dear friends. Do you think, can you tell me what can be the direction of acceleration? In first case, the direction of acceleration was same or opposite. Can you tell me what could be the direction here?
Vertical.
Instead of calling it vertical, my dear friends, call it perpendicular. Yeah, that is the correct term. If the direction of acceleration is perpendicular to velocity, if the direction of acceleration is perpendicular to the velocity, If the direction of acceleration is perpendicular to the velocity, only the direction of velocity changes. Do we understand this? Yes or no? Anyone please raise your hand so that I know. When the direction of acceleration is perpendicular, then only velocity changes in direction. Now, just apply some common sense. Velocity is like this. Velocity is like this. Acceleration is like this, downwards. In which direction will the velocity be? How will the velocity change in direction? Where will it go? Velocity is here, acceleration is downwards. How will it go? How will it turn? Because now it will turn, it cannot change the direction. It will turn. In which direction will it turn, beta? Just apply sense. This is not physics, this is common sense. How will it turn? It will turn, no? The direction will change. How will it turn? It will turn in the downward direction like this. Yes or no? That is how it will turn. Yes or no? You understand this? This is how it will turn. The magnitude will not change, it will turn. So whenever you are taking a turn, you're turning like this, your acceleration is like this. Are you getting my point, or it is going getting above our heads and saying bye bye, I'm going? Do we understand this, bacha? Now if my velocity is here and my acceleration is here, perpendicular, like this, how will this thing turn? How will this thing turn? Velocity is here, acceleration is upwards. How will this thing turn? No one?
Upward, sir.
Upward. So it will turn like this. Yes or no? You're turning your vehicle like this, the acceleration is like this. It will turn upwards. Now, as I told you in the previous case, here, this acceleration is known as tangential acceleration. Let me write T here also. Let me write T here also. This is tangential acceleration. It has a special name, tangential. Tangential. Therefore, this acceleration should also have a special name. Yes or no? This acceleration also has a special name. It has got many special names actually. It is known as AN. What do you mean by N? It is known as AR. Also, it is known as AC also. I'll just use any one of these. I will use N, AN, AN. This type of acceleration which changes the direction of velocity is known as normal acceleration. Do you understand the meaning of N? Normal acceleration. Do you understand the meaning of N or normal? What do you mean by normal? Normal means? What do you mean by normal? What do you mean by normal? Normal means it is perpendicular. Do we understand this? Normal acceleration changes the direction of velocity. Instead of calling it as normal, you can also call it radial. It's towards the center. You can also call it centripetal. And all these terms we will be discussing in great details In which chapter? The chapter known as circular motion. Right now, remember the name of this chapter is only motion in 1D. Therefore, this acceleration which changes the direction is not going to come. Do you understand this? The only acceleration that will come in 1D is the tangential acceleration. One acceleration changes the direction. The other acceleration changes the magnitude. How it can do both? How it can do both? Velocity changing in magnitude and direction both. I'll give you a minute to think about this. I want you to use your brains. Velocity is like this. Again, acceleration is a vector, and the most important thing about a vector is the direction. Everything depends on the direction. Can you tell me what could be possible direction for acceleration? And I want to do both. I'll give you a minute, think about it. Yes? Anyone? What could be a possible direction for acceleration? I want to do both things. I want to change the magnitude. I want to change the direction. Remember, this type of acceleration is not going to come here in this chapter. Here in this chapter, this will not come because this is motion in a straight line. But in the next chapter, motion in 2 dimensions, the body is going to turn. The body turns, this acceleration will come. How should be the direction of acceleration? So that it does both the things. What could be the direction? The direction, for example, could be like this. Now, this acceleration does both things. It changes the magnitude as well as it changes the direction, because I hope you have done vectors. I can resolve this acceleration in 2 components. One component will be along the velocity, the green one, which I can call as tangential acceleration. One component of this acceleration could be perpendicular. I can resolve it in perpendicular and parallel direction, and this would be the normal component. Now this acceleration, the red acceleration, is doing both things. It is also changing the magnitude of velocity. It is also changing the direction of velocity. Do we understand this? Yes or no?
Yes, sir.
Everyone, I don't see raise hands from everyone. Everyone understands this? Yes or no? Well done. Great. Everyone understands this. That is the most difficult part in understanding acceleration. Now, can you tell me, is the velocity increasing or velocity decreasing? B. Is it increasing or is
explain
it
once again.
decreasing? Yes?
Explain once again, sir.
Yes, beta?
Explain once again, sir.
I have broken the acceleration into 2 components. Acceleration can have 2 components. One component along velocity, one component perpendicular to the velocity. The component which is along the velocity is known as tangential acceleration. The component which is perpendicular to velocity is known as normal acceleration. Any vector can be broken up into x and y components. Yes or no? Have you seen this in vectors on a chapter? Yes or no? That is what I have done here, beta. I have broken acceleration A into two components, tangential and normal. Tangential component is going to change the magnitude. In this case, tell me whether the velocity will increase or whether the velocity decrease. Tell me, increase or decrease?
Increase, sir.
Well done, it will increase. Can anyone tell me how this is going to turn? Can anyone tell me how this is going to turn? Velocity is going to increase. You can see it from here. Velocity is going to increase because velocity and AT are in the same direction. Can anyone tell me how it is going to turn? How is it going to turn? Can anyone tell me how it is going to turn? Can anyone tell me how it is going to turn, beta? I'm waiting for your answer. No one understands. Either you know it or you don't know it. Don't know it, tell me, sir, you don't understand. I'll tell you the answer.
Downward, sir.
Downward side. Velocity is like this. Acceleration is downwards. Velocity is going to change in this direction. So it will turn like this, and velocity would be increasing. I'll give you one more, and I will give you 1 minute to think about this. Let us say velocity is in this direction, and your acceleration is in this direction. What happens in this case? What happens in this case? Does the velocity increase or decrease? Tell me.
Increase, sir.
Increase or decrease?
Decrease.
Decrease. Why will it decrease? Because if I break this vector, the tangential acceleration will come like this. So, well done. The velocity will decrease. How will it turn, beta? Find out the turning. Find out the turning. You have to see the direction of normal acceleration and my normal.
Downward, sir.
Well done, bacha. Well done. It will go to turn like this. Yes or no? No, yes. Do we understand this? This is your acceleration, my dear friends. And this is the acceleration which is written as two components and AN. We will understand more about this acceleration in the chapter on circular motion, my dear friends. I had to do this entire thing in circular motion, but I did it here. I do it here in circular motion. We will revise it. So this acceleration changes velocity. How does it change velocity? Acceleration changes velocity. It can have two. You can call them friends, you can call them brothers, you can call them daughters. It has two brothers or daughters. One of the brothers or daughters changes magnitude of V. The other brother, daughter, or cousin, whatever you call it, friend, daughter, brother, cousin, it changes the direction of velocity. Do we understand this, my dear friends? Is it clear to all? This is a very difficult concept. It is normally taught in your circular motion wala chapter, but I tried to do it here. I hope we have understood this. I'll give you 2 minutes to note everything down. If anyone has any problem, please raise. Everyone has noted this down, bacha? Well, then this is what I was telling you. This is put in a tabular form. 3 ways of changing the velocity. The first way is by changing the direction only. We call it normal acceleration. They called it the second way. To change the magnitude only, we call it tangential acceleration. In third case, we change force. So this is your total acceleration. That will be equal to tangential acceleration plus normal acceleration. You don't have to write it again. So just everything put in a tabular form. If you want to write it in tabular form, you can write it like this. If you want to write it in point-wise form, I've already told you how to write it in the point-wise form. This is the same thing put in a tabular form. Everyone understands this? This is a yes, this is a no. Can we move further ahead in life? Life has to move on. Can you move ahead?
1 minute.
Okay. Let me know when you are done so that I can move. Have we noted it down? Okay, that
No,
takes
sir.
us. You noted it down?
No, sir.
Okay, note it down. Shall we move ahead now? Are you done?
Yes, sir.
Okay. So we have seen the types of acceleration. We have seen it in the terms of what they do and what they don't do. One type of acceleration changes the magnitude of velocity. One type of acceleration changes the direction of velocity. Now we will again talk about the types of acceleration in a different way. The same way that we talked about velocity or speed, the first type of acceleration in that category will be known as uniform acceleration. Do we understand uniform acceleration? Yes or no? What do you mean by uniform acceleration? Tell me, Fatafat. Uniform acceleration, the other name for uniform acceleration, can also call it constant acceleration. Acceleration is same. So everything comes from the meaning of the term itself. What do you mean by uniform acceleration? Acceleration remains. Acceleration is same or constant
Rate of change.
or uniform with time. So acceleration is same or constant or uniform with time. That means it remains same in magnitude. It also remains same in direction. Do we understand this? It should not change in magnitude and it should not change in direction. That type of acceleration is known as uniform or same or constant acceleration. Do we understand this? I don't see anyone from the hyperactive class. Do we understand this? Hare, please. Do we understand this better?
Yes, sir.
Okay. Now, this is one way of understanding it. Acceleration remains same. You can also call it velocity changes by velocity changes equally. Velocity changes equally in equal intervals of time. This is not a very good way of saying this, but you can always say this. Velocity changes equally in equal intervals of time. You can also call it this way. One important note, a particle moving with a particle moving with uniform acceleration What type of motion it will have? Will it have a straight line motion or it can have curved motion as well? So remember, the motion can be straight line or motion can be curved as well in a plane. It is not necessary. This is one misconception that students have. They say, sir, if the acceleration is uniform, the particle will move in the same direction. Remember, particle can change its direction of velocity because that acceleration can have a normal component and the normal component changes the direction of velocity. Do we understand this? That uniform acceleration does not mean that the particle is moving in a straight line. Do we understand this? Uniform acceleration only means acceleration is constant. The particle can move in a straight line. The particle may be moving in a curved path. This is uniform acceleration. What is the second type of acceleration in this category? Fatafat, tell me.
Non-uniform acceleration.
Well done. And Fatafat write it. Non-uniform acceleration. We are short on time. Non-uniform acceleration. What is the other term that I can use for non-uniform acceleration? Tell me, bacha, fast. What is the other term that I can use for non-uniform acceleration? I can use variable acceleration. Now, what do you mean by variable acceleration? Acceleration changes.
Acceleration is not constant
Yes.
with
Well
respect
done.
to time.
Yes, it changes with time and it is not constant or same. Now, if it is not constant, it changes with time. It can change in what, my dear friends? It can change in magnitude. It can change in
Velocity.
direction. It can change in any of this, or it can change in both of this. Do we understand this? So, if the
Yes,
acceleration
sir.
is changing, it may be changing in magnitude. It may be changing in direction. It becomes non-uniform acceleration. Everyone understands this? Third type of acceleration. I wait for your turn. Third type of acceleration. What will be the third type of acceleration? Same classification. Yes.
Average acceleration.
Average acceleration. Well done. So everyone is following my notes. Average acceleration. Well done. And how will I define or how will I write average acceleration, my dear friends? I will use the same dabba. A, the vector, because it's a vector, put in a dabba. That becomes average acceleration. Now, you know what is average acceleration? Can you tell me what is average acceleration? It will be equal to total change in velocity divided by total time. Do we understand this, my dear friends? Total change in velocity divided by total time. That is my new friend, average acceleration. And now I can write a simple formula for this. A, acceleration, kappa means average, total change, delta V. Remember I told you delta V, delta is change. Did I tell you yes or no? Delta, this triangle, this is not triangle, this is delta, delta means change. That becomes Vf, final velocity minus Vi, initial velocity divided by T. You can write it like this, or you can write it as V2, final velocity minus V1, initial velocity divided by T, or you can write it as V minus U by T, doesn't matter. The first velocity is the final velocity, and the second velocity is the initial velocity. You can call them by different names. Doesn't matter. Do we understand this? Yes or no? No, yes. The only thing that matters is it is change. Change always means final minus initial. So I can write this equation in a different way. I can write change in velocity delta V will be equal to average acceleration multiplied by delta t. Do we understand this, or this is going above our head saying bye bye? I'm going, don't worry about me. Yes? No.
Yes,
Okay.
sir.
What is the direction of average acceleration? Average acceleration direction is same as the direction of delta V. You understand delta V is the change in velocity. The direction of average acceleration will be same as the direction of average velocity. Whenever I use the term average, my dear friends, it is always calculated over an interval of time. So it is always calculated over an interval of time or between 2 points. Whenever I calculate the average of anything, it is always between 2 points. Point A, point B. This is point A, this is point B. Find out the average. Average is always calculated over an interval of time, but there is something that is calculated at any instant of time. Can you tell me what is that and what is the fourth type of acceleration? Average acceleration is calculated over an interval of time. What is the fourth type of acceleration? Yes, my dear friends, I know you have the answers.
Instantaneous acceleration.
Instantaneous acceleration. Instantaneous acceleration, and I think we call it
Sir, can you
A.
show previous one, sir?
Instantaneous acceleration A vector, and I simply write it as A vector.
Sir, can you show the previous one, sir?
Write it down fast. So the writing speed should be fast. Cannot survive if you are slow, beta. Written? Okay. The last type of acceleration is instantaneous acceleration. What do you mean by instantaneous acceleration? It is the acceleration at any instant. Right now, what is your acceleration? That is your instantaneous acceleration. And I write instantaneous acceleration as dv by dt. It is also, you can also call it as rate of change of velocity with time. And as soon as I hear this term instantaneous acceleration, it's the rate of change of velocity with time. I also understand that whenever I have used the term A or acceleration, whenever I have used the term acceleration, my dear friends, which acceleration do I mean when I say my acceleration is this thing? Which acceleration do I mean? It is same as saying my velocity is this much. When I say my velocity is 5 meters per second in the east direction, which velocity am I referring to? When I say my speed is 5 meters per second, which speed I am referring to? I always refer to my instantaneous speeds or instantaneous velocities or instantaneous acceleration. So this acceleration, which is instantaneous acceleration, is what we call as in normal language the acceleration of the body. Do we understand this? Yes or no? Everything is coming same. In the next class, what we are going to do is to move ahead and see the equations of motions. We'll also see some questions on acceleration, and we will go ahead with that. I hope you are solving the sheet that was given to you. Please keep on solving those sheets. Those sheets are given in a very comprehensive manner. The questions are subdivided into distance, displacement, 1D, 2D, no, 1D, then uniform velocity, non-uniform speed, and acceleration. So try to do the part with acceleration,
Third one, show the previous one, sir.
and I will see you in the next class. Take care. Have a nice day, beta.